Let's solve this radical equation. Might be a little bit lengthier because there's going to be a good amount of explanations and some reminders in it. We have n equals the square root of n plus 12. So in this equation, we do have a radical, but we also just have a standard variable, both the same. But anytime we want to solve a radical equation, we need to isolate the radical, and it is isolated on the right, even though there's a variable on the left. It doesn't really matter. We're just going to square both sides. I'm going to square this side. I'm going to square this side. And what's going to happen, as mentioned before, the square root, the radical, and the square, they cancel each other out, just leaving us with n plus 12. And that will equal n squared. So now it's kind of like, well, where do I go from here? If I wanted to solve for this n, I would take the square root, but then I'd be back to the beginning of where I was. If I want to solve for this n, I'd take away 12, and it's not really going to work. So we got to think back. When have we dealt with variables with exponents being squared? This becomes a quadratic equation. All right, we are dealing with a quadratic. And to solve a quadratic, we normally just want to get it into standard form. So I'm going to put everything on the same side and make it equal to 0. So I'm going to take away an n. I'm going to take away a 12. I'm going to take away the n from the other side. And I'm going to be left with n squared minus n minus 12. And that now equals 0. And now I have a quadratic equation that we can solve multiple ways. I could graph this, no way. I could use the quadratic formula, absolutely could try to do that. But the first thing I often want to try is just, is it factorable? Can I factor this? So are there two terms that multiply together to give me negative 12, but will add to give me this coefficient of negative 1? So if I add them together to give me negative 1, one has to be positive and one has to be negative, because when they multiply, they give me a negative. Let's see here. I have an n and an n. Multiply together to give me 12, so that gives me 12 and 1, 6 and 2, 3 and 4. But when I subtract them, I get negative 1, meaning they have to be 1 apart. So that tells me it is going to be a 4 and a 3. But now, which one's going to be positive, which one's going to be negative? Since my b value is negative 1, my larger of the two has to be negative. All right, that's a little review on factoring. So now I have the equation n plus 4 times n minus 3 equals 0. I want to solve this. So it gives me n minus 4. This binomial could equal 0, or this binomial could equal 0. So I will solve this one. I get n equals 4. I will solve this one, and I get n equals negative 3. So I have my two solutions, 4 and negative 3. With a normal quadratic, if this was just our original equation, we would be done. Both of these would work. But that wasn't our original equation. Our original equation was n equals the square root of n plus 12. That was our original equation. These are the solutions that we found. Okay. What we have to do is test both of them to see if it works. All right. I have to check them. I'm going to start with my 4. Does 4 equal the square root of 4 plus 12? Does 4 equal the square root of 16? The square root of 16, yes, that is 4. All right, it always can be 4. All right. Now, what that means is that, yes, this is a solution. Now I want to check negative 3 to see if that is also a solution, meaning it will end in a statement that is always true. So I'm going to rewrite the equation. Instead of using 4, I'm going to use, does negative 3 equal the square root of negative 3 plus 12? So does negative 3 equal negative 3 plus 12, root 9? Does negative 3 always equal the square root of 9? Meaning if I take the square root of 9, will it always equal 3? Not necessarily. The square root of 9 can equal positive or negative 3. This is saying always negative 3. That's not true. This is not a true statement all of the time, which means n equals negative 3 is an extraneous solution. All right, it's an extraneous solution, which means although it is an apparent solution, we got it with solving it, when we plug it back into the original equation, it is not always going to be true. So the solution to this equation is just n equals 4 with an extraneous or not always working solution of -3.